Let's get started on page 32. Which sequence of transformations will map triangle ABC onto its image? Okay, so we're looking at our figure and we're trying to go from ABC to the image. Keep that in mind. Your original is the triangle on the right. Okay, so going through each one of these options, you're going to pick a point and you're going to see if it works. It has to work for every single point. Now, let's start with the first one. You're going to rotate 90 degrees clockwise. Now, before I go ahead and do this, I want to take a look at my figure. You should know where your figure ends up after a rotation. If I'm going clockwise, like the hands of a clock, I'm going to move in this direction. If it's 90 degrees, that means I'm only going to move across one quadrant. So, looking at my figure, that's going to mean that my triangle is going to go clockwise one quadrant. It's going to end up on the bottom right. Now, it should end up on the top left. So I know automatically this is not going to be a correct choice. Now, looking at the second choice, we have a rotation counterclockwise 90 degrees. Now, going from this triangle, the original, counterclockwise one quadrant will end up in the top left. It will end up exactly where this triangle is right now. Now, I'm going to erase my marks here. The way that you want to rotate is you want to physically turn your paper. Now, I'm going to pick one point to do that with. If I pick point A, for example, and I go 90 degrees counterclockwise, in other words, I turn my paper to the left, you should see that A is now going to be located at -3, 0. So if you rotated 90 degrees, it's going to end up right here at -3, 0. It does work. If you tried for each one of the points, counterclockwise 90 degrees does work. Now let's take a look at some of the other choices. I'm going to check off that yes, the second one does work, and let's take a look at the third one. So erase some of my marks. Now, it says a reflection across the x-axis, followed by a reflection across the y-axis, and then a rotation 90 degrees clockwise. Okay, let's take a look. I'm going to pick one point and I'm going to see if it works. So the first thing it said was that you were going to reflect across the x-axis. So let me go ahead and pick point A. Again, reflecting across the x-axis, I'm going to count down 1, 2, 3 boxes, down 3 again, 1, 2, 3, and I end up here at 0, -3. Then it says to reflect across the y-axis. Since I'm on the y-axis, point A doesn't move. So after the reflection across the y-axis, I'm still here at 0, -3. Lastly, it says rotate 90 degrees clockwise. So yes, this point A should go clockwise. Imagine it's at 6 o'clock right now. It's going to go 7, 8, 9. It's going to go 90 degrees clock. You're going to turn your paper to the right 1/4 of a turn clockwise. And what you should see is that your point is going to end up at -3, 0. I'm not going to do it with you because we've had a lot of practice with that. So I think you can go ahead and turn your paper and it will end up at -3, 0. That's exactly where A prime is. You should also do this for points B and C. So just as a quick recap, if I were to take point B and reflect it across the x-axis, it wouldn't move. It would still be here at 5, 0. If I then reflect it across the y-axis, then I would count 1, 2, 3, 4, 5, then go 5 again, 1, 2, 3, 4, 5, and I end up here for B. After that, I have to go clockwise 90 degrees. So again, I'm going to go clockwise 90 degrees. So that's going to be in this direction. Again, clock. If you turn your paper, you should end up at 0, 5 right here. And you would see that yes, it does work. It should work for all of the points. So we are going to go ahead and select that the third choice is correct. And now the last choice. You're going to do a transformation according to the rule xy becomes x, y minus 3. If you see addition or subtraction, you're doing a translation. You're moving left, right, up, down. Since only y is being affected, that means you're only going to move down because it's minus 3. Down 3 boxes and that's it. You don't move left and right, you just move down 3. So after going down 3, you're going to follow with a rotation 90 degrees counterclockwise. And after that, translate left 3 units. So 3 different transformations here. Let's try them out. Going to erase all of this. Zoom in. And now I'm going to start with A again. So it said A, we're going to go x, comma, y minus 3. So we talked about that. It means down 3. 1, 2, 3. All right, so we end up at 0, 0. That's where A is. After our transformation down 3, we're going to rotate 90 degrees counterclockwise. Well, if our point is on the origin, it doesn't matter how much you rotate, your point's not going to move. So I'm going to stay at 0, 0 after my rotation 90 degrees counterclockwise. You could turn your paper, and you'll notice it's still going to be at 0, 0. Then the last one says you're going to move left 3 units. Translate left 3 units. Okay, 1, 2, 3. And I end up right here at A prime. That's exactly where I want to end up. You shouldn't just stop at A. You should try it for all of the points. So let me go ahead and pick B. So B, I'm going to go down 3. 1, 2, 3. I end up here at 5, negative 3. My next step is to go counterclockwise, 90 degrees. So counterclockwise is in this direction, opposite the hands of a clock. If I go ahead and I rotate counterclockwise, I'm going to end up at 3, positive 3, positive 5. So positive 3, positive 5 if I rotate 90 degrees. And lastly, I'm going to go left 3 units, they say. 1, 2, 3. If I do that, I end up at B prime, which is where I want to end up. If you try this for C, it should work as well. It should work for all of the points. But if you tried C and it didn't work, then you don't select the choice. But I'm going to tell you that yes, it does work. Make sure you try C for yourself and make sure that you get to where C prime is at negative 3, 5. So I'm going to go back to my choices. And I'm going to go ahead and I'm also going to select this last choice. So we have 3 different selections here. So the key, make sure you're trying every single point for each one of the selections to make sure they all work. Sometimes it works for 1 point or 2 of the points, but not for all of them. So you want to try out all of them when you're taking a big state test. Okay, let's keep it moving. Number 159, complete the algebraic description. Now take a look at your algebraic description, your rule. Notice that we have addition symbols here. And just like in the last problem, if you see addition or you see subtraction, you're translating. It's a translation, which means you're just sliding. Left, right, up, down, you're sliding. You're doing a translation. Now, to complete this algebraic description, you have to pay attention to which is your original figure and which one is the new. Our original figure is here. I know that it's original because it doesn't have those little tick marks. Our new figure is the one with the primes. So we're looking to go from the blue figure to the yellow figure. All you have to do is pick 1 point to follow. So I'm going to pick point C. Point C goes to the left. 1, 2, 3, 4, 5 boxes. Moving left 5 is a negative movement. So I'm going to put minus 5. And then we have going up 1, 2, 3. That's a positive movement when you go up, so that's plus 3. Now keep in mind, your x values are the ones that control left and right movement. Your y values are the ones that control going up and going down. So in my algebraic description, I'm going to put that x plus a negative 5 gets me left 5. And then for my y value, I'm going to add 3. With the positive and the negative here, it's going to end up being x minus 5 like we're used to seeing. But in terms of filling in this visual and filling in this shell of a translation, you're going to put in just the negative 5. Okay, and we're done. Pretty quick question. Number 160, another transformation question. Determine the sequence of transformations that maps the figure onto its image. Select all that apply. Now you have to, again, figure out which one's your original and which one's your new figure. This is the original. It's going to turn into the one on the top left. Okay. Now, let's get started. Each choice. Rotation 180 degrees about 0, 0. So we're rotating 180 around the origin. It's always around the origin, so you can ignore the fact that it says 0, 0. Rotating 180, that's going upside down. Followed by a reflection across the line x equals 5. And then a translation right 1 unit. Okay, 3 different transformations. Let's start with the rotation 180 degrees. Now, I do like the rule for rotating 180. I'm not a big rule person, but I do like the rule for rotating 180. Rotating 180 tells you to change the sign of both x and y. So it's going to be negative x, negative y. You change the sign of both. So for example, if I pick point L right now is at 4, negative 3. 4, comma, negative 3. Applying the rule means I'm going to change the sign of both coordinates. So it's going to become negative 4, positive 3. So now L, negative 4, positive 3. So I end up right here where Q double prime is. That's my L. The next step after we rotated 180 is to reflect across the line x equals 5. Now x equals 5. You're going to go to the x-axis where x is 5. So x equals 5 is right here. An x equals line is going to have to pass through there. So we're going to make our x equals line vertical. In fact, if you remember how we went over hoi vux, vertical, vux. Well, actually, it looks more like a U, so let me change that. Vux. It means it's going to be vertical when you see an x equals line, so that it can pass through wherever it says x is equal to. In this case, x equals 5. So we're going to count. Starting with L, where we left off, we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes to get to the line of reflection. Same thing on the other side. 1, 2, 3, 4, 5, 6. Now I'm going off the graph. 7, 8, 9. Right now, L is going to be at 13, comma, 3. So it's off the graph. If you have a larger graph, wonderful. But right now it's at 13, comma, 3. The last step, it says it's going to go right 1 unit. So one more box to the right, we're going to end up at 14, comma, 1. It's definitely not where we want it to be, which is at L double prime. So our first choice is not going to be correct. Not going to be correct. Okay. I'm going to go ahead and I'm going to clear this off. And we're going to try the next choice. So no to the first one. Okay, second one. Reflection across the y-axis followed by this rule. xy becomes x, y plus 6. Notice the addition. So if it's addition or subtraction, that means it's a translation. Left, right, up, down. In this case, since we're adding 6 to the y, all we're doing is going up. We're not moving left and right because there's nothing being added to the x or subtracted from x. So again, let's pick a point. Let's try this out. So a reflection across the y-axis. Let me pick point L again. And let's reflect across the y-axis. So count to the left. 1, 2, 3, 4 to get to the y-axis. 4 again. 1, 2, 3, 4. So here I am at -4, -3. That's L. Now the next one says you're going to take this and you're going to do the translation x, comma, y plus 6. So we're going to go up 6. 1, 2, 3, 4, 5, 6. I end up at Q double prime, but not at L double prime. So I didn't end up mapping onto the image. I mapped onto another point. So second choice is not going to work because it doesn't work for point L. So again, no to the second choice. Let's move on to the third. A reflection across the x-axis followed by a translation left 9 units. Okay, simple enough. Reflection across the x and then left 9. I'm going to erase all of this and let's try this out. Again, I'm going to pick point L. Oh, fix that. I'm going to pick point L. So point L. Reflecting across the x-axis. So I'm going to count up to get to the x-axis. 1, 2, 3. Up 3 again. 1, 2, 3. I'm here at 4, 3. And then it says it's going to go to the left 9 units. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it ended up at the right point. Let me pick another one. So I'm going to pick N. That's pretty far away from L. I want to go really far away from from L to see if it'll work for that next point. So again, reflect across the x-axis. Count. 6 boxes up. Let's go 6 again. So now we're here at N. So before we were at 9, -6. Now we're at 9, +6. Notice when you flip over the x-axis, all you do is change the sign of y. So we went from -6 to +6. Okay? And now it says go left 9 units. So let's go ahead and get started. So we end up here at N double prime. 0, 6. Yeah, it works. In fact, you could try it for all of the points and all of them are going to work. So we are going to go ahead and select the third choice. Last one. Translation up 9 units followed by a reflection across the y-axis. So we're going to go up 9 units and then reflect across y. Let's go ahead and try it out. Again, I'm going to go ahead and erase all of this. This was an X. Okay. So again, I'm going to pick point L and stay consistent. Zoom in. So point L. Translate up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we're going to reflect across the y-axis. So L right now is here. Let's flip over the y-axis. So counting 1, 2, 3, 4 to get to the y-axis. 1, 2, 3, 4 again. And we're here. L. Well, that does not match onto L double prime. So no, it does not work. It doesn't work for L, so it's not going to map the image onto the pre-image onto the image. So note to the last choice. So the only correct choice here was the third choice. Even though it said select all that apply, only the third choice worked. Okay, let's keep moving to the last question on this page. Number 161. Triangle RST undergoes the transformation XY becomes 2.5 times X, 2.5 times Y. Now you have to know what it means when you see multiplication happening to both coordinates. When you see multiplication, that means it's a dilation. Only dilations multiply your coordinates. So here it says, select the choice below that describes why the transformation does not result in a congruent figure. So we know that after a dilation, you're not going to get a congruent figure. Not going to get a congruent figure, because a dilation changes the size of an object. Let's take a look at your choices. Choice A. A rotation does not preserve orientation. Therefore, triangle R prime, S prime, T prime is not congruent to the preimage. Well, we're not even talking about a rotation, but a rotation does make a congruent figure. So this whole part just does not make sense. Rotations do preserve size, and they do preserve orientation. So none of this is actually correct. B. A dilation preserves distance between points and orientation. So they are talking about a dilation, but they're saying that it does preserve distance. Well, let's talk about what a dilation does. Imagine this is your line segment, AB. After your dilation of 2.5, let's say that this was originally 2, and then we're going to dilate. So we're going to make this 2.5 times bigger. So now your new figure is going to be 5 units long. The distance between these 2 points has changed. It's not preserved. It's not preserved. So this is incorrect. A dilation does not preserve distance between the points. That's exactly what a dilation does. It changes the distance between 2 points. So we're going to say no to the second choice. C. A dilation, so I like the fact they're talking about the dilation again, does not preserve distance between points. That's exactly it. A dilation does not preserve distance. That's the definition of a dilation, is that it changes the distance between points. So I'm selecting choice C right now. Let's check the last one. A rotation does not preserve distance. Well, a rotation does preserve distance. It doesn't change the size of an object. A line segment will be the same length after it's rotated. So that's not correct. It's only choice C. Okay, let's move on.